Hello everyone, my name is Priyanka and I welcome you all to my session. So let's read our question, which says that using Rutherford's model of the atom, derive the expression for the total energy of the electron in the hydrogen atom. And what is the significance of the total negative energy possessed by the electron? Alright, so we know that as per the structure of atom, there is the nucleus, that is the core part, and then the electrons are revolving around it. So, when the electron is revolving around the nucleus of an atom, then obviously there is going to be a centripetal force. So, that centripetal force is provided by the electrostatic force of attraction. So, the formula of centripetal force is mv square by r. So, the centripetal force is provided by the electrostatic force of attraction. So, the formula of electrostatic force is equal to 1 upon 4 pi epsilon naught Z E square by R square, where Z is the atomic number of the atom, R is the radius of atom, E is the charge of an electron, and m is the mass, v is velocity, r is the radius. So we're going to cancel one of the r, and therefore we can say that mv square is equal to 1 upon 4 pi epsilon naught Z E square by R. So we're going to name it as equation 1. Now we are knowing that the total energy of an electron is the sum of kinetic energy and potential energy. So I'm going to write total energy as TE, which we have to find out, which is the sum of kinetic energy KE and also the potential energy. So that's the standard thing that we are knowing. Remember, here the potential energy, we don't mean to say by mgh, but it is electrostatic potential energy. So, what is the formula of kinetic energy? It is simple, half mv square, and the formula of electrostatic potential energy, which is equal to minus z into E square upon 4 pi epsilon naught r. So, the formula of the force and the potential energy is almost the same, except that in the force the denominator was having r square and here it is just r. Okay, so from equation 1 we can take the value of mv square, so we can write it as half into Z E square upon 4 pi epsilon naught r, and here it was minus Z E square upon 4 pi epsilon naught r. So it is 1 upon 8 pi epsilon naught r Z E square minus Z E square upon 4 pi epsilon naught r. So finally we're going to get our answer as minus 1 upon 8 pi epsilon naught Z E square upon r. So that's the value of the total energy. Now for an electron, for an hydrogen atom, Z is equal to 1. Z is equal to 1 for an hydrogen atom. Therefore, we can say that the total energy would be given by minus 1 upon 8 pi epsilon naught E square by R. Okay, so here we can see that in total energy there is a negative sign, right? So this negative sign implies that the electron is a bound or attractive system. We can say that this electron nucleus is a bound or attractive system. So this is how we're going to derive the total energy of an electron in the hydrogen atom. So thank you so much for your time. Have a great day. Bye bye.